Hey guys, Mr. Larson here. Just wanted to walk you through some notes for coming up with linear functions from context. So today we'll talk first about what a function is, what makes a function linear. We'll break down an equation, and then we'll do two different examples where we're defining variables and coming up with our equation for our function. Okay, so first thing, what is a function? We talked about this last week. A function, it's a relationship between x and y, where every input, our x value, has no more than one y value, or one output. And then remember, when we talked about functions, we called this y value our f of x. Okay, so those are interchangeable when we're talking about functions. So what makes a function linear? There's different types of functions, and what makes it linear, if you think about a graph, when we graph, the first four letters of linear is line, right? That's where that comes from. So when we graph a linear function, it looks like a line. Okay, so that's where that name linear comes from. So what causes our graph to look like that line? Well, we're going to talk today about rate of change. And rate of change refers to how one variable changes with the other variable. Okay, so when we have a linear function, it means that rate of change is constant. No matter when we look at how the variables relate to each other, that rate of change is always the same. So if you think about a line, remember when we were plotting, we would plot like the y-intercept, and let's say the slope was 1 over 2. By the way, rate of change, when we're talking linear, another name for that is our slope. But if we were going up 1, right 2, up 1, right 2, up 1, right 2, right? When I keep doing that constantly, right, it's the same thing over and over. That's what gives it a linear shape. Okay, so the rate of change is constant, and that's key. So we've talked a little bit, and I'm sure you're familiar with y equals mx plus b. This is our slope-intercept form. Okay, for a linear equation or a linear function. And when we're building this from context, we need to start filling in what these different values are, right? So let's just talk about what they represent. So B is going to represent our starting value. Okay, what are we starting with? Y is going to represent your final value. M is going to represent your rate of change. We also said that's like your slope. Okay, you probably heard that as slope. And you just want to think like, how much am I adding every time, right? How much am I adding every time? We're thinking about addition when we talk about linear functions. So that's another way to think about that is, what am I adding? And then X is a little tricky. Sometimes we think of it as the number of time periods. Sometimes it's the number of t-shirts that you're selling. It might be the number of gym classes that you're going to. So it's really tough to put an overall label on it. But it's the other unknown value. And a lot of times you can tell what it is by looking for keywords like per or for every, okay, or for each. All right, so a lot of these are keywords, and when you see that, that's a lot of a good way to tell that that's going to be your X value. That's going to be your other unknown value that you're defining. Okay, so I know this is a little abstract, but I think once we do a few examples, it becomes a little bit easier. So what we're going to do here is kind of build a process for coming up with our equation or our function, and keep in mind that we could also replace y with f of x if we're saying it's a function. Okay. So for example 1, it says that Brian ordered a number of soccer balls. Each soccer ball cost $40 and shipping costs $6 for the entire order. Define your variables and write the linear function that describes the scenario. Okay, so first thing I like to do is underline my known and my unknown variables, and we can list them out. So my known, I'm sorry, not variables, values. So my known values. So I know $40 per soccer ball. I know there's $6 for shipping. Okay. What values don't I know? Okay. Well, let's see. I don't know the total cost, right? In dollars. And let's look for those keywords. I see the word each here. Each soccer ball. I don't know how many soccer balls I have, right? So number of soccer balls. So for each of these unknown values, I want to create a let statement, or I want to define my variables. Okay, so let's see. I want to let y represent, and we said y was going to be our final value, right? Well, the total cost is like our final value. Okay, so the total cost in dollars. All right, and we said that x is going to be that other unknown value where I have like each or for every or per. So that would be the number of soccer balls. Okay, so now I want to develop my equation, and let's see, y equals mx plus b. So my final, y is the final cost in dollars, so I don't know that. I'm going to say y equals, and then m times x. Well, m is my rate of change, or what I'm adding every time. Well, every time I sell another soccer ball, or order another soccer ball, it's costing me $40, right? I want to multiply that by my x variable, so times x, which is the number of soccer balls I'm selling, and then I always have that $6 in shipping. So we said like starting value, final value, rate of change, unknown value. We can think of it like this. I'm starting with a $6 charge, right? Regardless of how many soccer balls I order, it's going to cost me $6. I'm going to build up to this final value by adding $40 some number of times, right? Depending on how many soccer balls I end up ordering. Okay, so I'm going to get charged $6 plus $40 times however many soccer balls I order, and that's going to tell me my final value. Okay, my final cost. Again, we could change this to f of x if I want to make it in function notation. Okay, so let's do another example here. Grace charges $5 to walk your dog, plus an additional $3 per block that she walks. Wow, that's an incredible business model. All right, so what are my known values? Well, it's $5 for the walk, okay? $5 per walk. Let's see, I shouldn't say per walk, let's say $5 to walk. We know it's $3 per block. Okay, what are my unknowns? Well, $3 per block. I'm looking for that word per, right? So when I see per, well, that's per block. I don't know how many blocks I'm walking, right? So number of blocks, that's unknown. That can change. And then the other thing is my final cost, right? What's my cost going to be? So the total cost in dollars. All right. So let's do our let statements. We have two variables, y and x. We said the one with that per is usually going to be the x variable. So let's say let x represent the number of blocks that we walk, that Grace walks. And I'm going to let y represent the total cost in dollars. Okay. So let's see, what's this total cost going to be? How am I building up to that? Well, I have a starting value or starting cost of $5, right when I sign up to have my dog walked. Then it's going to be $3 times however many blocks Grace walks. And that should give me my final value. Okay, so y equals mx plus b. So my final value is going to equal, we can think of it like, all right, your starting value plus $3, which was my m, times the number of blocks. Okay, so the other thing I want to point out is that you're gonna always have y and x that remain as your unknowns, because those can change, right? Those are your variables. Those can change. The other two should be able for you to figure them out. So like that, the slope or the rate of change, this m value, that should be within the context of the problem, right? The starting value, that should also be inside the context of the problem. So you're always going to have y and x remain as y and x. Again, y could be changed to f of x if you wanted it to. But those other two values, your rate of change, your m, and your starting value, which is b, those you should plug in numbers for to develop your equation or your function. Okay? All right, guys. Hope that helps.